Hello everyone, welcome to the new edition of this channel. We are to continue from where we left with the engineering science. Last time we were talking about how you have to use the sine or the cos when you have an inclined force or maybe an inclined speed, which you have to calculate the north and the east from that. So today we are going to be talking about relative velocity. Now I want you to understand relative velocity in the normal way, like the day-to-day things you see moving around you. So I want you to imagine that you are at the bus station or maybe the train station, and you sit maybe anywhere, and as soon as the train arrived and the train is leaving, you see as the train increases its speed, it's getting farther away from you. So at the point, the train relative to you, it's going to be the train speed. So let me put this in perspective. Imagine this is you and this is the train at the same point. Now in 0 hour, this is 0 hours. Now imagine the train is moving, let's say 60 kilometers per hour. So this is you, this is the train. Let's say this is the train. Let's just keep this is the train. Now excuse me. Now in 1 hour it's traveling 60 kilometers per hour. So obviously in 1 hour it's going to travel 60. This is, now it's going to be 1 hour. Now this is 0 kilometers per hour. Now this is 60 kilometers per hour. What about in 2 hours? In 2 hours it's going to be 120 kilometers per hour. Now the simple thing you need to understand here now is the relative velocity of the train relative to you. It's 160 kilometers per hour when it's in 2 hours. Now what about in 1 hour is 60 kilometers per hour. That means as it increases, so here it's 60 kilometers per hour, and when it reaches here, you see it's double the time. Now here is also 60 kilometers per hour. So if you want to calculate the relative velocity, it's going to be 120 kilometers per hour. So the distance at which the train has moved away from you. Now let's look at this. Let's look at this now. If you are working at 7 kilometers per hour due north, now let's draw this graph. Due north, this is north, this is south, this is west, this is east. So you are traveling due north at a rate of 7 kilometers per hour. Now what is your velocity relative to the ground? So in this case, the ground is this, the point of 0. Now you have been asked your relative to the ground. So let's name you A, let's name this B. Now your velocity relative to the ground. Normally the formula for relative velocity is given as A B is equals to VA minus VB. Now let's take into perspective the relative velocity of what? Let me see. If you are working due north, what is the relative velocity? What is your velocity? Now your velocity, which is A, sorry. Now the relative velocity, which your velocity relative to the ground. Now what is your velocity? Let's name that A is equals to 7 kilometers per hour. I told you that if a force here is moving upward, the y direction is positive. It's moving downward, the y direction is negative. So the force is moving upward, so it's positive 7 kilometers per hour. Now what is the velocity of the ground? So ground is B is equals to 0 kilometers per hour. Now let's put in this formula. So VA P is equals to, what is your VA? Let's name this VA and VB. So your VA is simply 7 and your VB minus 0. So this will give you 7 kilometers per hour. That is your velocity relative to the ground. What about the velocity of the ground velocity relative to you? Now this will invert. This will be VBA, which is going to be VB minus VA. Now, what is your VB? VB is equals to 0 kilometers per hour. VA is equals to 7 kilometers per hour. So there you are going to get, let me reduce this, minus 0 is equal to 7 kilometers per hour. So here you are going to get VBA is equals to VB. Remember, VB is the ground relative to you. VBA is going to be the relative velocity of the ground relative to you. So it's going to be 0 minus 7, which is obviously going to be 7, negative 7 kilometers per hour. Now, in a negative sense, it tells you that it is moving in the opposite direction. The opposite direction to the north is going to be due what? Due south. Here is due north. So that is how you calculate relative velocity